Using advanced lightweight materials gives lower fuel consumption, more payload and reduced emissions. It also gives new functionality.
The use of smart and intelligent materials will offer new functionalities which give a more attractive ship to the operators in the shipyards. But the lightweight effect is not achieved by light materials, but by adding functionality. One example might here be an adaptive bulbous bow.
Using these new, lighter materials also means challenges for the designers. How do you create a new design when there are no rules or guidelines for the materials? IMO, the International Maritime Organization, is responsible for the safety and security of shipping and the prevention of marine pollution by ships. Also, classification companies like DNV, Germanisch Lloyd, Det Norske Veritas, Lloyd's Register make guidelines and regulations. In shipbuilding, plastic composite can in many applications replace steel or aluminium. It has a very high specific strength and E-modulus, which gives low weight and a freedom of design, as it is possible to make advanced geometries at an acceptable cost.
It sounds strange, but still a lot of our ships that built are still finished in the Netherlands. I think the efficiency of Western European countries is that much higher, also from a technology point of view. Put it in a bit more personal perspective. 6 years ago I went to China, and this year I went again. But this year it cost me twice as much. The difference in production cost compared to the transportation cost will be starting to become negligible.
Looked at over an entire life cycle, the new lightweight construction means lower fuel costs, lower maintenance and no need for scrapping. On top of that, an environmental life cycle analysis will also show positive figures. The Eco Island Ferry project made a conceptual ferry of carbon fibre that showed opportunities for fuel cost savings and reduction of environmental impact.
The Eco Island Ferry project is a combined research and marketing project directed to those political and financial decision makers out in the municipalities, small ferry companies who really do not know what weight means. And the idea was to take an existing, fairly new steel ferry, redesign it into carbon fiber composite, see how would it look like today. And we want to demonstrate that we, with a lower weight of course, could have a lower fuel consumption by making simple resistance versus power calculations. We want to convince people that if they were looking at the total cost over the ship's lifetime, it would be more beneficial to buy the more expensive carbon fiber ferry.
European competitiveness is based on the ability to be innovative, have efficient production and cooperate, and there is no need to give up on our competitiveness.
If you would like to sell a new product, an innovative product, which is really new, then you have to convince the potential customer. You can calculate for him that it will pay off after a few years. You need to find a mode to help him to reduce his risk. So one way would be that I sell you the product including a service contract. And with this service contract I make sure that my product, which is new and it's also risky for me to sell it to you, but with a service contract I can make sure that it is well maintained, that it is treated well. I learn from you using it, and maybe I have to modify it a little bit to adjust to your particular needs. And this way we both have a win-win.
Offshore operations are increasing, and demands for safety and working environment are key factors for construction and operations at sea.
We identified further studies, for example living quarters, helidecks, lifeboat platforms. That in this case is a stability issue, as having a steel structure hanging on side of the platform. Retractable gangways. This is the connection between the living platform and the production platform, and should work in very hard condition, but it should be quick release in case of emergency.
EU is a fantastic possibility to create collaboration and get support through several of the European Commission's programmes.
Everybody seems to be aware that FP7 projects deliver very often excellent results, but the move to the market is a weakness. It's often that the industry likes to look at academia as being removed from the market, and academia doesn't want to be necessarily spoiled by selling stuff. As we heard, the language of the ship owners is money. Same goes for the utilities, energy sector, etc. Stuff needs to be developed and then sold. I think we have a good collaboration between industry and the policy makers for setting the directions. It's not that we are getting it too wrong in my view. We have a target for SME involvement. I know it's traditionally very difficult to activate SMEs in research because either they are very busy with doing their thing or they are on the brink of extinction, and very often they just don't find the time. The potential of the seas, coasts and oceans for sustainable business exploitation. It has to be sustainable, clever, smartly managed. That requires a lot of basic research and even understanding how the oceans function. Blue biotech, as I said, there is a lot of the material, the biodiversity is not known. That might be interesting for biocomposites, for example, also to look into things like there. Lightweight structures, I think some planktons are amazing constructions that are sometimes even mimicked. I have seen one project where the foundation for windmills, offshore windmills, is mimicking basically a biostructure. We can learn a lot from these creatures that have been around for a couple of billion years. Ocean energy, so far we have offshore wind, it's relatively mature, but the potential is more in the waves, maybe the currents, tides. There's a lot more to be researched there. And again, we might need lightweight structures because putting steel has certain disadvantages. For corrosion, it's a hostile environment. You want to keep the moving masses low, etc., for example, in wave energy. Aquaculture so far is very much a coastal business, but we're going to have a protein shortage, and with climate change it could be quite dramatic what we get from land-based agriculture. So aquaculture needs to maybe fill a gap here. And we are thinking about combining applications, so having a floating offshore aquaculture facility that generates its own ocean energy.
Conventional steel ships will surely dominate the seas for a long time, but lightweight construction materials will most likely be used in all areas where the advantages can be seen.
I think composite materials have a great future for the shipping industry. In particular, the possibility to produce carbon neutral ships. I think that is the future for the shipping industry. To combine it with great sources of power for the ships gives a great potential for the ship owners to work with the carbon dioxide neutral future. As was stated quite a few years back, this is the material for the future, but now it's the material for right now, and the future is here. So composite materials can make a big difference for the societies right now, here and today. It's exciting to see that what you do makes an impact for the future societies.
This is an arena for the maritime sector to cooperate internationally for sustainable transportation and economic growth.